Hey, have you ever written code that just feels slow? You run it and the output is correct, but it takes more time than you expected. The truth is, sometimes the problem isn't you, it's that your code hasn't been optimized yet. That's where compilers come in. In this video, I'm going to show you how compilers can take your code, clean it up, and make it run faster, all without changing what it does. We'll explore three common optimization techniques: dead code removal, loop unrolling, and inlining. And by the end, you'll see exactly how these tricks can cut your program's execution time in half or even more. Code can run slow for many reasons. Maybe the algorithm is inefficient, maybe there's extra code that isn't needed, or maybe memory is being used poorly. But a compiler is more than just a translator from your source code into machine language. It's also a performance booster. In this session, we'll dive into some of the ways a compiler can improve your code automatically. Compiler optimization is the process of transforming your code so that it runs faster, uses less memory, or both, without changing its actual behavior. For example, if you write x square, the compiler might replace that with a bit shift operator, which is mathematically the same but runs faster. And the beauty of it is, these optimizations happen automatically during compilation. Dead code removal is exactly what it sounds like. The compiler finds and deletes code that will never be executed. This not only makes your program smaller, but also reduces the amount of work the CPU has to do. You can think of it like pruning a tree, cutting away dead branches so that the healthy parts can grow more efficiently. Loops are powerful, but they come with overhead, checking conditions, jumping back to the top, and so on. Loop unrolling is a technique where the compiler expands the loop so it performs multiple operations in a single pass. It's like unpacking several boxes at once instead of opening them one by one. The work gets done faster because you avoid repeating the step up for each step. When you call a function, the program has to pause, jump to that function code, run it, and then come back. Inlining removes that pause by replacing the function call with the function's actual code. It's like skipping the trip to a store and having the item instantly appear in your hands. No travel time, just results. Optimizations generally fall into two categories: machine independent optimizations, which work on any platform, things like dead code removal, loop unrolling, and inlining. Machine dependent optimizations are tailored to specific hardware, like scheduling instructions for a particular processor or choosing the most efficient registers. Both work together to give you the fastest possible program. Optimizations aren't always free. Some can make your program run faster, but at the cost of longer compilation times. Others might boost performance but make the final binary larger. The goal is to find a balance between the time you spend compiling and the performance gains you get when the program runs. So here's a real world case. We have two versions of the same program, one without optimization and one with compiler optimizations turned on. The optimized version runs twice as fast as the original. And here's the best part, the programmer didn't have to change a single line of code. In this specific example, execution time dropped from 120 milliseconds to 60 milliseconds. That's a 50% speed boost. And with more advanced optimization, you can sometimes see improvements of 2 times, 5 times, or even 10 times. So to recap, dead code removal gets rid of instructions that will never be used. Loop unrolling reduces the extra work loops do. Inlining eliminates the cost of function calls. Together, these techniques can make your code run significantly faster without you having to rewrite it. A good compiler really is your silent performance coach, making your programs leaner, faster, and more efficient. Follow Shadow Compiler for more interesting content. Thank you.